Welcome back, Algebra 2.1. What we are going to be doing today is the bell work, homework quiz, graphing functions, and then a Desmos activity, and that is it. This Desmos activity is hopefully going to tie a lot of things in with domain and range, how it relates to functions, how it relates to graphing functions, but then also how it's going to be relating to what we call piecewise functions, and that's going to be tomorrow. Let's get to it. I have a couple questions here for the bell work on homework quiz, graphing functions to prepare you for the homework quiz. So let's get right into it. Let's not waste any more time. Given the slope and the y-intercept, what is this as a graph? So my slope is 3, my y-intercept is 2, and so literally I'm just going to slope it, guys. It's very simple. So this right here and then up 3 over 1. So 1, 2, 3 all over 1. Right here, it's going to look something like this-ish. It's that simple. I mean, you can graph it on Desmos, you can graph it on whatever. It's literally just that, okay? So you're going to get a question, excuse me, you're going to get a question like that on the homework quiz or something similar to it. Find the average rate of change. How do I find the average rate of change? Well, this is your formula. I'm going to put it up here. F of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. This is your formula. What does that mean? It means I'm going to use this. This is your function. Okay? Now watch what I'm about to do. This is going to change into this. So I'm going to first put brackets. I'm going to use x sub 2 first. I'm going to plug 4 into my function. So that means it's going to be 4 squared and then plus 6 times 4. Okay, that's what it means. 4 squared and then plus 6 times 4. I'm going to plug in 4 into there. I'm going to find my y. What I'm really doing here is finding my y output in the midst of also finding slope. And then minus, because that's what my formula says, brackets. I'm going to get rid of some of that stuff here. And then brackets, I'm going to plug in to this formula. I kind of just did it again. Man, I'm so stupid. Plug it into this formula, not x sub 2, but x sub 1 now, which is 2. Okay, so that is going to look like 2 squared, and then plus 6 times 2. Sorry about that, guys. All over, following my formula, x sub 2 minus x sub 1. So that means 4 minus 2, because that's x sub 2 minus x sub 1. How can I do this in brackets? 4 squared is 16, and then that's going to be plus 24. 6 times 4. Minus, still in brackets, 2 squared is going to be 4, and then 6 times 2 is going to be 12, so plus 12. End brackets, and then this is going to be 2. I'm going to move my little face here. I have enough room to work. What does this equal? This is going to be 30. So I'm going to leave the brackets off right now, and then minus, and this is actually just 16 all over 2. I'm actually going to divide both by 2 right here, but you can, either way, it's just 14 and then divided by 2, which is 7. Or you can take 15 because you divide by 2 here, divide by 2 here. So 15 minus 8, which is still 7. But your average rate of change is 7. Okay, so those are 2 examples. I think I have one more. Let's get to it. I'm going to erase. I hope that makes sense. If that doesn't make sense, go back and watch the video real quick, or go on to Math Excel, see if you can actually get more help. All right, 2 more. Okay, what is this one? What is this one? Well, this is just going to tell you to graph. So it says use transformations to graph absolute value functions. And this in particular, so first of all, I know that this means reflection. So this is a reflection across the x-axis. So I'm going to say that. Reflection, x-axis. That's what it means. This -1 means not going to the left. It actually means going to the right. So it goes to the right, let's not up. So it goes to the right 1. And then this right here, it means actually down 5. So I'm actually going to graph it on Desmos, and I'm going to show you what that means. Okay. So I have y equals negative 3. I can do my absolute value bars, which is right here. X minus 1. Notice how I'm starting to get something. And then minus 5. So let's look back here. So negative 3 times the absolute value of x minus 1 minus 5. Now some of you may be wondering, how did I get the absolute value bars? If you go to my functions, I can find my absolute values right here. Okay, I don't want it right now, so I'm going to delete it. Or you can do shift, and it's right underneath your backspace key. If you do shift and then press that button, that's the button. So if I press the button right there, it's like a forward slash. But if I do shift, it gives me your actual absolute values. Okay, so what is this? What does it look like? It's actually very nice. I'm going to scroll up right here. This is what it looks like. This is what we call a vertex. That's your y-intercept. Pretty cool, right? So what you're going to be doing is honestly just on not Desmos, but on Math Excel, you're going to be finding a graph that looks similar to this, and you're going to be marking A, B, C, or D. I mean, that's really that simple. You don't need to do anything else besides graph it on Desmos, and then boom, there it is. Okay? That's simple. Graph it on Desmos. If you don't know. But if you do know all this stuff, and that's great, then you can pretty much deduce it from there. It's going to go reflect across and so forth. Remember, our actual absolute value parent graph looks something like this. That's what it actually looks like, but it shifted. It shifted a lot. It kind of stretched up because the 3 kind of changes it a little bit, kind of makes it a little bit more skinny, as you can tell. So from the 3 to the parent graph in purple here, to the green, our actual graph, what Math Excel wants, and then our parent graph, you can see it definitely transformed it in a little bit. It transformed it into something different. We're going to spend more time on that on Friday during our Desmos activity. Okay, and this one right here, what it wants us to find is find the slope of the line passing, and then determine the line, whether the line passes, rises, horizontal, vertical, and so forth. Okay, whether or not it falls or rises, I don't really need to know the actual equation, although we could find the equation. But let's go to town. I like stacking them. That's just my go-to. So when I find my slope, boom, boom, negative 6 minus 3, and then boom, boom, 3 minus 3. And so I see down here at the bottom, I mean, I can solve the top if I want, but down here at the bottom it's 0, which means this is undefined. So it's going to tell you whether or not it's undefined if there's a 0 in the denominator. If there's a 0 in the numerator, let's just say it looks like this. This is what we call a slope of 0. So this is your slope of 0. Now let's just say it's a negative 2. If your slope is negative 2, what does that mean, guys? It means it falls. So your line looks something like this. It falls down. What if I had a slope of 2, a positive number? It means it goes up. Okay? So we're going to spend a lot more time on why that is in Algebra 2.2, but again, it's just precursing it and getting used to functions, how it relates to what we know, what we learned in Algebra 1, really. Okay, so I'm going to race, and let's get you guys started on the homework quiz. I love this little thing. My cat's like that all the time. My cat begs for water, and then when I don't give her water from the sink or the tub, when I don't turn on the water from the sink or the tub, she basically acts like that, like, I can't even deal with you, and so forth. And yeah, she's a furball. Homework quiz, 5 questions, 25 minutes, open notes. When you're done with that, please get started. You can click on this on the slides, and it'll take you right there. You don't even need to put in the code, so that's amazing. So get started on that. Please review your answers. If there's a negative off, or you forgot parentheses or something, or maybe you got half the fraction or something like that, please send it to me, and I can possibly help you with partial credit, okay? We have 25 minutes. Get started on that. Please, please, please make sure you are being mindful of your time so that you're not overworking yourself. So when you're taking a homework quiz, don't rush it, is what I'm saying. Okay, take the time. Take the full 25 minutes if needed. As soon as you're done with that, come over here. Go to student.desmos.com, type in the code, or you can go on the last slide and just click on that. What we're going to be doing, guys, is really just practicing finding domain and range of what we call piecewise functions. Okay, what are piecewise functions? We're going to learn more about that tomorrow. That's really what we're going to be doing. Tomorrow is going to be piecewise functions. I wanted to kind of go through it a little bit earlier. However, you will begin with an informal exploration of domain and range. That's true. We should already know what that means, so it's going to be kind of a review of last week with functions, just analyzing graphs and so forth. And then we're going to be using what we call piecewise functions using inequalities. Now, this is very, very important stuff. If we were in class, we would do a piecewise functions project, but we're obviously not in class, so we can't. That's okay. I don't really care. Other than that, it's going to be a very, very beneficial, I think, a very beneficial Desmos activity for us all. So let's get started. What you're going to be seeing here is something like this. What do you think domain is? You should absolutely say something like, okay, domain is the x values, it is the inputs. Okay, so a mathematician says something is wrong with this shading graph. Okay, what do you think that is? Well, first of all, right here, domain is the set of all x values of which the graph exists. Well, look at this shading here. There's a little bit something wrong here, and that's what we can say. Look at this. There's this little block of this block of shading that doesn't necessarily match up with my graph. So what I need to do is technically move this just a little bit over. And if you want to say that, you can, but I need to move it to the left. Just a little bit over. It seems like just slightly, like maybe 1 or 0.75 over to the left. Okay? That's what I definitely need to do. Why is that? Because when I go to the next slide, mathematicians use this type of shading to represent the domain of a function. To the exact measure of the domain of a function, we include all of the x values that the graph crosses, or all of the x values in which the graph exists. So now that we can move this, okay, I want to move it right there. Okay, try to get to the best ability right there. Boom. What does that mean? That means it's right at 4. Okay, so if we continue on the next slide, you're going to see something like this. Oh, I'm a little off. Okay, so now I want to change it, and that will make it right at 4. Okay, so if it's just a little bit off, I want to fix it, so correctly represent it. So I want to write the inequality. And you can click on this, and it's awesome because it actually teaches you how to. I had a lot of students tell me, like, how do you type this in or how do you type that in? This is how you type it in, how to type in math expressions on Desmos, by the way. So feel free to use that. But honestly, this is the cool part, guys. Right here, this is what we call set notation. This is what we call, actually, no, it's not what we call set notation. It's what we call inequality notation. I'm going to show you set notation. Set notation is a little bit more fancy, but this is what we call inequality notation. Now, what is set notation? Set notation is something like this. The set of all x such that x is less than or equal to x, but it's also less or greater than or equal to x, but it's also less than 4. Okay? Now, interval notation. And this is something that we're very familiar with. Interval notation looks something like this, guys. I'm going to look at this and do 1 bracket and then going all the way to 4 parentheses. This is my interval notation. We're going to be spending a lot more time on this because I think interval notation is used more in mathematics than all the other ones. But this is set notation, set notation right here. Inequality notation is what this Desmos activity will be using. But I'm also going to transfer it to what we call interval notation. Okay, interval notation is something that we're going to be using, what you did use or should have used last week. Okay. And as a reminder, guys, what you see here is actually what we call a piecewise function. So this is what we call a piecewise function. We're going to get more into this tomorrow, but this is what it is. It's like a piece of a function. That's why we call it piecewise. Okay? You don't need to know that today. We're going to learn how to graph them and how to do all sorts of fun jazz with them tomorrow. But this, I'm just letting you know it's a piecewise function. So let's erase. Let's continue on here to the fourth slide. Now you want to fix it. So fix it just using the inequality. Now, before I do that, I want to show you what the interval looks like. What does the interval look like? The interval looks like this. I mean, what is that point? I'm not so sure. Like, it's kind of fuzzy. And what is that point? Okay, so if we go and click on this point, we can see your x is negative 1.5. This point is 1. So negative 1.5 to 1. Now watch this. Since that's closed, I'm going to do brackets. So negative 1.5 and then to 1 parentheses. This is what my interval notation looks like. Okay? Because it's looking like this. That's where it exists right here. Okay? So let's change this. Okay? Let's change it. So I'm going to do negative 1.5. And now I'm going to change this to 1. Now what do you notice here? What's different is that 1 is dotted and 1 is solid. Well, I want this one, the left one, to be solid, right? Because it's brackets. It's included. There's a point here. It's actually included. This point's not included. How do I do that? Well, I just have to go right here, click right by my x. I hope you're following along. Click right by your x and just hit an equal sign. And that will change it. So that's all I did was I just hit an equal sign. Hit an equal sign. Hit an equal sign right there, right by the x. And it'll automatically adjust. And if you didn't know that, you can go ahead and type this. And it'll actually show you how to type certain things. Okay? Just certain things. Basic symbols. Okay, so if I want an equal to sign, I just hit it, equal. So now it fits. Awesome. So let's continue on. Now for 4 possible answers for screen 4, which one it is, you can adjust the inequality in screen 4 if it helps. I mean, clearly we already did it. Okay, it's this one right here. And I know it's this one because, obviously it's solid right here. This is 1.5. My x, I'm only looking at the x. I don't care about the 1.75. That's my y value. I only care about the x value, and that's negative 1.5. Why do I care about the x, Mr. Carlson? Because it's domain. Domain is your x values, your inputs. Okay, so I don't care about the y values right now. I only care about the x's. And then right here, it's also my x is 1. So since I care about my domain, what represents the domain? So negative 1.5 to 1, that's what I want. And then I want solid right here, so equal to and then not equal to dash. So it's definitely that one. Okay, make sure you explain that adequately. Going on to the next slide. This is another piecewise function. It looks fantastic. What is the domain? Be careful to use less than or equal to, or less than, greater than or equal to, or greater than, and so forth. Now, I look at this. These are my points, right? And just because it has like a little sharp point here doesn't really mean anything. Now, when you get up to higher level math, it actually does mean something. Okay, because what this really means is it goes from here. That's actually a really nice line. It goes from here to here. But actually, the problem with this is this. I mean, this point doesn't really, it exists, but in higher level mathematics, it doesn't exist. But I'm pretty sure we're just going to say it exists. And then it keeps going, and then it gets here, and this is going to be dotted. So what does that mean? What should I type in? Okay, what I should type in here is from negative 5 equals, because it's a solid. Remember, guys, over here, this is negative 5, right? I'm only caring about my x. And it goes all the way to 10. So that means 10, and since it's not, equal to, it has a dashed line. I can submit that, and then boom. Was I right? I was right, because I'm awesome. You know what I mean? Look at that. Beautiful. That's exactly what I want. Let's move on to the next slide. Okay, what is the domain of this function? What do you think? Try to do this one by yourself. Look at the x values. I'll give you a hint. I'll give you an interval notation. How about that? And then you can try to do the inequality right here. So what it wants is the inequality. Don't put the interval notation. Put the inequality here. Okay? I'm going to give you the interval notation. It goes from negative 6 to 8. So what does that mean? it means bracket -6 to not -8. Oh, shoot. -6 to 8. Okay, so this is the interval notation. Okay, just FYI. You need to find the inequality notation. So go ahead and try to do that. I'm going to erase. All right, now here we want to drag the points and try to match with each piece. Again, this is what we call a piecewise function, and I want to try to match with each piece. All right? That's what I really want to do. I want to try to match with each piece here. So that means I see solid, solid, I see 2 dashed, and then I see a solid and a dashed. So what I want to do is I want to drag my solids to my solid. So that's my solid to my solid. And then I have 1 dashed and 1 solid. And I see that this is open and that's also closed. So I'm going to actually do that. So I'm going to drag that all the way over here and then drag this right there. Okay? Trying to get to the best of my ability here. Now I have 2 dashed, so I'm going to drag it all the way over here and drag it all the way over here. Now, maybe you're wondering, why is this one dashed? I mean, you just don't see the end of the point. That's a good question. If we never can see the end of the point, we're always going to assume it's not included because it could continue on forever, right? So since this continues on forever, hopefully to infinity, that's going to be a dashed line. So what does this look like for domain? That's an interesting fact. This right here looks like -9. This looks like some number. What is that number? -3. That looks like -2, 4, 5, and then infinity. So let's write that. -2, 4, and then 5, and then infinity. Okay, so what does this look like with interval notation? I challenge you to try to figure it out before moving on. See if you're really good at interval notation. Where does the graph start to exist? -9, comma, -3, bracket. I jump, union, I jump from a new piece. So that means I go now to parentheses, -2, comma, 4, bracket. And then union, parentheses, 5, comma, infinity, parentheses. This is what it would look like if I wanted to do interval notation. Pretty cool, right? So you see, how many intervals do I have? 1, 2, 3. How many pieces do I have? 1, 2, 3. Okay, so I have 3 pieces. I have 3 intervals. So I hope you notice now, okay? Those of you who struggled with functions last week, the functions homework quiz, hope you notice now that your interval notation is each piece of the function, of each piece of your graph here, okay? And that's the important part, each piece. I love that. That's awesome. You can put it almost right on top of each other, and that's what it is. I should have written it down here. Let's erase this. Let's move on. I'll only go through a couple more with you. Now I want you to find, just straight up the challenge, find what the domain is. I'll give you a hint. Okay. This is going to be -6. I'll give you a hint by using domain interval notation. And this is going to be the -3, bracket, union, and then starting right here, that's going to be -2. So parentheses, -2, and then -1, and then union, and then this is going to be 1 to 3, bracket. This is what it looks like in interval notation, but yes, you're going to be using inequalities. So I swear to you, if I see anybody pasting this right here, I'm going to get super pissed. Okay? Use inequalities. I'll even start it with you. How about that? I'll start it with you. Is that all right? Use a new line for each region. Use -6. Okay? X. See how it's shading? Pretty cool, right? And then I'm going to use equals and then -3. Boom. So that's my first one that I want to say. Like, awesome, right? Pretty cool? I think it's pretty cool. It shades it. Pretty cool. You want to do the next piece? -2, -1. I'll even start half of this one for you. How about that? -2 and then x. Okay? And then what other number goes there? I sure hope you do -1. Finish the next piece. That's what you should be doing. Okay? And then this is the slide that I will end with you. Exploring range. Range is literally the exact same thing as domain, but instead of going left to right, we go bottoms up. Okay, so it's every point along the curve is closed dot unless you actually see an open dot. What does that mean? Okay, what is my range here? This is a solid line, so I need to make sure I put it right here. This is a dotted line. I need to make sure I put it right here. Okay. Now some of you are thinking like, oh, well, there's nothing that includes here. It doesn't matter because it's right here. So you see that there is a function attached to one end of the shade to another end of the shade. If there's no gap into the function, you did it right. So then you can go to the next slide and you can see pretty much the exact same functions, but then you can start including, okay, how can I first change this? I need to be able to change right here, this inequality to match this. I'm going to leave you with that. Finish the rest. I already helped you way too much. I hope you enjoy this Desmos activity. I hope you kind of learn a little bit more with how functions relate to domain and range, and also Desmos. We're going to learn about piecewise functions tomorrow because we're actually going to graph those babies tomorrow. And yes, graph them and do a little bit more work with them. So make sure you complete this Desmos activity as your homework. Make sure you complete other homework that you haven't yet to get to. Finish the homework quiz if you haven't finished the homework quiz for graphing functions and for proportions and simple rational equations. But until next time, guys, it's been real. This is C Squared Mathematics. Peace.